Welcome to the Food Tech. In today's video, we're diving deep into clean-in-place systems in dairy plants. Clean-in-place systems are an essential component of dairy plant sanitation, allowing automated, efficient, and consistent cleaning of processing equipment without disassembly. CIP systems ensure that pipelines, tanks, pasteurizers, homogenizers, and other dairy processing equipment remain free from microbial contamination, product residues, and mineral deposits. This system enhances food safety, maintains product quality, and ensures regulatory compliance while minimizing downtime and labor costs. Principles of CIP systems. CIP is based on the controlled circulation of cleaning solutions through equipment, surfaces in a sequence of rinsing, washing, and sanitization steps. The effectiveness of CIP systems depends on four key parameters, often referred to as TACT. Time, the duration of each cleaning cycle, ensuring adequate removal of contaminants. Action, turbulence, the mechanical force exerted by the cleaning. Solution flow to dislodge residues. Chemical concentration, the appropriate use of detergents and sanitizers for effective cleaning. Temperature. Optimal temperatures enhance the dissolution of fats, proteins, and mineral deposits. A well-optimized CIP system balances these factors to achieve thorough cleaning with minimal resource wastage. Steps involved in CIP systems pre-rinse. The first stage involves flushing the system with water to remove loose product residues. This prevents excessive contamination of cleaning solutions and prepares surfaces for detergent application. Cold or warm water may be used depending on the type of residue present. Detergent wash. A specialized detergent solution is circulated to dissolve fats, proteins, and mineral deposits. Alkaline detergents, such as sodium hydroxide, are commonly used for removing organic residues, while acidic detergents, such as nitric acid, help eliminate mineral buildup like milkstone. The detergent solution is circulated at a controlled temperature and flow rate to maximize cleaning efficiency. Intermediate rinse. After the detergent cycle, the system is rinsed with water to remove residual chemicals and dislodged contaminants. This step prevents detergent carryover into the sanitization phase. Sanitization. A disinfectant or sanitizer is circulated to destroy any remaining microorganisms. Common sanitizers include chlorine-based compounds, peracetic acid, iodophores, and quaternary ammonium compounds. The choice of sanitizer depends on factors such as microbial target spectrum, environmental safety, and equipment compatibility. Final rinse. A final flush with potable water removes any traces of the sanitizer, ensuring that no harmful residues remain in the system before production resumes. Some dairy plants use sterile or ozonated water for enhanced microbial control. Types of CIP systems. Single-use CIP system. Each cleaning cycle uses fresh detergent and water, ensuring maximum hygiene but increasing water and chemical consumption. This system is preferred in operations with stringent hygiene requirements, such as infant formula or ultra-high temperature milk processing. Recovery CIP system. Cleaning solutions are partially or fully reused after filtration and chemical concentration adjustments. This system is more economical and environmentally sustainable, but requires advanced monitoring to maintain cleaning efficacy. Automated CIP system. Fully automated systems with programmable logic controllers regulate cleaning parameters such as time, temperature, flow rate, and chemical concentration. These systems provide consistent cleaning results, reduce manual intervention, and optimize resource utilization. Semi-automated CIP system. A combination of manual and automated control, where certain steps, such as chemical dosing, may require human supervision. This system offers a balance between automation and cost efficiency. Advantages of CIP systems. In dairy processing, consistent cleaning. Automated and standardized cleaning cycles ensure uniform hygiene across all processing equipment. Time and labor efficiency. Eliminates the need for manual disassembly and cleaning, reducing downtime and increasing production efficiency. Reduced chemical and water usage. Optimized cleaning protocols minimize the excessive use of water, detergents, and sanitizers, enhancing environmental sustainability. Improved worker safety reduces exposure to hazardous cleaning chemicals and minimizes the risk of workplace injuries. Regulatory compliance ensures adherence to hygiene standards set by regulatory authorities, such as the Food Safety and Standards Authority of India and the Codex Alimentarius. Challenges in CIP implementation. Residue buildup. Inefficient CIP cycles can lead to the accumulation of milkstone, biofilms, or fat deposits, compromising food safety. Microbial resistance. Inadequate sanitization can result in persistent microbial contamination, requiring periodic validation of cleaning protocols. Equipment compatibility. Some detergents and sanitizers may cause corrosion or degradation of stainless steel surfaces, necessitating proper material selection. Cost considerations. The initial investment for installing an advanced CIP system can be high, although long-term savings in labor and resource use justify the expense. If you found this video helpful, hit the like button, subscribe to the Food Tech, and turn on notifications. For more insights on food safety and technology, have any questions? Drop them in the comments below.